today we are going to solve this largest plus sign problem. So this is a DP problem. So we are given like two arguments. One is n, where basically it says like we are having a matrix filled with 1 for n cross n. So it would be a square matrix, and we are having mines. So what does mine represent here? Like wherever we are having mines for I comma j, so there we would be having 0 like this over here. So we were having like 4 at 4 comma 2, so fourth row and second index. So 0 1 2 3 4 and 0 1 2. So this is our mine. So like this there would be mines and other things. So in order to solve this, like one way in order to solve this is like traverse the matrix, and whenever we encounter one, we need to do a search like a DFS search. So from one, we'll go on the top. What is how many elements on the top are there that are one in a contiguous manner. Same goes when we need to go on left, we need to go on right, and we need to go down. So suppose when we are here, so we will go up one, left one, right we will go 3 times, and same below we will go 3 times. So, and the minimum among those would be like 1 itself. So but that is like a pretty brute force solution, but there is a turnaround if we could memorize the result. So suppose if you already know, like when we are at this particular one, how many one are above than this, how many one are below than this, how many one are right to this, and how many ones are left to this, and then we can just take a minimum of those, and we could just simply return that value. So the same thing we are going to do now. So I've already written up the code because it's a lengthy code. So I've created like 4 array, above, right, below, and left, and our matrix itself. So initially it would be initialized with 1 itself, and then what we are doing is wherever the mines are, we are just making sure that those points are converted to 0. After that, what we are doing is we are filling up above and left because those can be filled up together. So what we are doing is means like if we encountered 1 in the matrix, then what we will do is we will sum up the value, and if we do not encounter 1, if we encountered 0, then we will just make the value as 0 itself, and we are keep going to do this. So like here what we are doing is if we are getting the matrix value is 1, so in the else part, so in this part we have already checked if matrix is 0, then we will place both of them as 0, and then we will continue. Else when the matrix value is 1, then what we are doing is we are summing up with its previous value also. Like for left, what is my left hand side value, so that like we get like contiguous kind of things for each and everything, like that we will do. Same goes for below and right. So below, just in order to make sure, we need to start it from the rightmost portion. So in this array, so we would be, for below and right, we need to start from this index, and for above and left, we need to start populating from this. So that will give us like the correct output. So same way we are doing this. Only thing is to make sure that we are, instead of checking for zeros indexes, we need to check on the rightmost indexes like in -1 and all those kind of things. And instead of like checking a previous index that was already populated, so right and below would be having indexes greater that are already populated because we are populating it from down. So suppose when we are at 1, so this would not be filled up. Only this one would be filled up. So we need to check up this in below. So like, so that does make sense. So we are filling those up. So like that, we have created this, and just for the sake of this example, I've like populated this, and then what we are doing is this is our main logic basically. So in this, what we are doing is if the ith and the jth index contains a value of 1, then we are taking a maximum value and of the maximum sign that we already have initialized with 0, and we need to take the minimum possible value among above, left, right, and below. So why is that? I will tell you. Like suppose when we are at here, at this particular one, so on above we are having 1, on left and right also there is like 2 2, okay, and below is 0. So sorry, on above is 3. So if we take like maximum value here, so it will give us like 3. That is not the correct answer because we cannot create plus at this particular index itself. So we need to take the minimum possible value, so that it will return us 0, because this 0 is the minimum possible value. So the same way, this will return us the minimum possible value, and then what we are doing is we are doing 1. So there is a base case condition So suppose if we are having like a single matrix and there are like no minds. So and we have initialized, then the plus sign that we could create is of like one index only. So that is something within here itself. So just in order to make sure, then we are doing a plus, and then we are returning the maximum sign. And so just to show you like how does it work. So suppose this is our initial matrix after making sure we have changed the minds, and this is my above matrix. So like on above, the first row itself would be 0, and the subsequent rows are addition. So like when I'm at this particular index, this particular one, so I will check like how many ones are above. So there is only one, and when I'm at this, so similar way. So same way like here, so we can see like 2, and here we are only having 1 because the above one is not considered. So contiguous one is only 1. So same way we have populated up this, and this is my left matrix, this is my below, and this is the right part. And so let's try to run this and see if this works. Output okay. So I think we need to remove this up. So let's see. Yep, it got accepted. So cool. This was a good problem. We can consider this as a medium level problem because this is dynamic programming and we are memorizing the results already before doing that. So yeah, this was an interesting problem. Only the problem was like it requires a lot of code to be written. So I don't expect those from Leetcode, but overall basis, this was a good problem. Cool. Let's see what comes up tomorrow. Thanks.